So sorry about that. Going back, I just forgot to start the recording. It's a little early for me. So we're talking about the weighted mean. It's a new measure of central tendency, and it's an average of some type. Okay, and what a weighted mean is it occurs when you have some observation that you wish to place more importance on than others. So some observations more important for some reason. So what that concept means in mathematics is what we want to do is we want to weight them more somehow, or weight those values more. Okay, that's the whole concept of a weighted mean. We have some data set, but for some reason within the data set, some observations are more important than others. So to do this, we have to have two variables. Okay, we have to have what we call a weighting variable. All right, and we must have the original variable. Okay, and what this weighting variable does is it indicates the importance to place on any given observation or how much we want to weight it. Okay, so we denote the original variable by x sub I and its corresponding w or weighting variable as w sub I. So what that means is if we have the first value in our data set x sub 1, that gets a corresponding weight w sub 1. Our next value in the data set x sub 2 gets a corresponding weight w sub 2, and so on and so on and so on. Okay, the weights have to correspond to the actual value. Okay, so here's the formula for the weighted mean. Okay, we're always just going to denote it as x bar weighted, or I'll just say the weighted mean. There is no dual notation for this. Okay, and the way you take a mean, obviously it's just a sum divided by the number of observations there are. So the weighted mean is just a little different. It's still a division problem. Okay, but what you're noticing here is we're going to take each weight and multiply it by its corresponding value. So I'm going to write it a little differently. It's the first x value times its corresponding weight. Like if you look back here, each x value has a weight. And then you're going to go to the next x value in the data set, and you're going to multiply that by its corresponding weight. And notice how I'm writing it as x times w instead of w times x here. That's totally fine, right? Because like 5 times 4 is the same as 4 times 5. All the way till you get to the last value in the data set times its corresponding weight. All right, so show this as shorthand. This was a little bit from the lectures online. Does anybody remember what this notation means in mathematics?
Sum.
Yes, the sum up. So here's what we're going to do. We're going to sum each x value times their corresponding weights. And instead of dividing by how many there are, so remember n represents how many data values there are, you're going to have to divide by the sum of the weights. All right. So actually the mean you've learned before from the mean you've been doing, so like a traditional mean, is just a weighted mean. With each weight, each w sub I, each weighting variable equal to 1. Okay, so actually like an arithmetic mean, or the sample mean, x bar, or mu, the population mean, it's actually just a weighted mean, just we're weighting each value as 1. Okay, so this is our formula for the weighted mean here. How might we use this? So I came across this data set a number of years ago, and I was really surprised by some of the values here. Okay, so this was taken from a government website, and what it lists here, what it shows here is it shows the life expectancy in a group of Northern African countries, right? So we have Algeria, Egypt, Libya, Morocco, Nigeria, Sudan, and Tunisia, okay? Or Tunisia, depending on how you pronounce it. Who has the highest life expectancy here? Which country has the best life expectancy from this group of 7 Northern African countries?
Libya.
Libya.
Yeah, it's not bad, 73. Okay, this is the highest here. Okay, but there's one that's like a little scary, right? Or it's very unfortunate. Which one has the lowest life expectancy?
Nigeria.
Yeah, right. Right, I'm almost into my 40s. That's a scary life expectancy, right? Life expectancy in Nigeria is to live to be 41 years old. So there's a little bit of variance or variation here, excuse me, across all the values. So if you were to just take a normal average just from these 7 values, you'd sum up all these values, you get 422, divide by the 7 countries. So this would be the mean, I'm going to put life expectancy LE for the 7 countries, counting each one equally. Okay, what I mean by equally is they all have a weight of 1. We say each value is equally important to the data set. Now let me give you another bit of piece of information about these countries, okay? Here what you have now, you see is the population of each country. Okay, so counting them equally, the mean life expectancy is 63.14 years of age. But now look at the population of each country, okay? Who has the lowest population?
Libya.
Yeah. Look here, Libya has the lowest population. So what we're seeing here is it has the highest life expectancy, lowest population. Okay, who has the highest population? Someone has it here in the chat.
Nigeria.
Yeah. So Nigeria, whoa, look at this. So 5 million people live in Libya, but 126 million people live in Nigeria. So this one has the lowest life expectancy, but the highest population. So can anybody tell me maybe why it's unfair to just look at the straight mean here? To just take a normal mean?
Professor, I guess because the data is significantly high and low in the numbers.
Your mic was a little low there, so I couldn't hear you too well.
There's a lot of difference.
Yeah, there's a lot of difference, right, in the population, right? So like if you look here, basically what we're saying here is Nigeria has roughly a 25 times as many people in it as Libya. So what we should do, oh, you're okay, don't worry about your mic. So what you should do here is you want to count this much better. You want to count it not much better, but much more, okay? So what we want to do here, instead of just doing a normal mean, a weighted mean might be better. Okay, weighted mean might be better. But the one thing you don't want to do with a weighted mean is you don't want to use weights of numbers like 1, 2, 3, 4. That's not what you have as weighted means, okay? So there's 2 variables here in this data set. So if you look back here, we have an original variable and we have a weighting variable from our data set. Okay, so what was the original thing we were interested in? Life expectancy or population?
The life expectancy.
Yeah, so this is going to be our original variable, x sub I. So then what are we going to weight it by? We're going to weight it by the population. This will be our w sub I. Okay, so look, we have our x sub I and our w sub I. So what this means is we're going to take the Libya value of 73 and we're going to weight it with the number 5. We're going to take our life expectancy in Nigeria of 41 and we're going to weight it with a value of 126. Okay, so that captures how relevant they are to the data set. Okay, so if you look back at our formula, I have another slide here. Our formula for the weighted mean was the sum of each x value times its corresponding weight divided by the sum of the weights. So here was our x value, here was our weights. So what you're going to do is you're going to take each X value and multiply it by its corresponding weight. So you would take for Algeria, you would take 68 times the 31 million people who live there. You would get that number. And you would keep doing this. Until you got all the way to the last value in the data set. So this one right here. And you would sum all these numbers up. And that gets this value right here, 16,627. Okay, now how many countries were there in this data set? Yeah, thank you, Brittany. So what you can't do here is you can't take this number and divide it by 7. Okay, because if you were to take this number, 16,627, and divide by 7, you'd get a number like 2,000 something. Okay, so it's a much higher number, right? Like it's so large it doesn't make sense. So here's why you divide it by the sum of the weights. So like 31 plus 70 plus 10 gets this number, which is 302. And when you take this divided by this, you get a much more accurate picture of the life expectancy in these 7 countries. So on average, if you account for the population of each country, the average life expectancy is 55.05 years. Vast difference between the 63.14. It's like an 8-year difference. It's crazy. Okay, but makes sense why you would need perhaps the weighted mean here?
Yes.
Okay. All right, I just want to do one more quick example that you maybe you know or don't know is a weighted mean, but an actual GPA, a grade point example. So calculating a student's grade point average, okay? So at the end of the semester, right, you'll get your grade report and it'll have your GPA on a 4.0 scale. And so I want to show you how that's calculated using actually a weighted mean here. So we'll have this student, okay? And we'll just call the student Matt after me, okay? And we want to calculate this student's GPA. So let me tell you the classes that this student is taking. He's obviously taking statistics. Okay, that's the best class ever, right? Let's say he's taking Calculus 1. That's a pretty good class. Okay, he's taking an English class because he has to. He's taking an economics class. All right, and then let's just say he's taking a gym class. He's taking running. All right, let me give you the grades this student gets. Student Matt, what grade do you think he's going to get in his statistics course?
Probably 100.
Obviously an A.
Absolutely, he's going to get an A. Absolutely, thank you. You guys are right. He'll probably get an A in calculus. You know, I'm a terrible writer, so I'll probably get a C in English. Maybe I'll get a B in economics. And then I'm a terrible runner, okay? So let's say I get a D in running. Ugh. Okay? Let me give you the numerical grades for these now. Okay, on a 4-point scale, an A is worth a 4, a C is worth a 2, a B is worth a 3 on a 4-point scale, and a D is worth a 1. Okay? So if you were to just take an average here of this, all right, you would sum these up 4, 8, 10, 13, you'd get 14. He's taking 5 classes. If you take 14 divided by 5, we would say his GPA is a 2.8. Okay. But do you think that's how the GPA is actually counted for this student, Matt?
No.
Okay, so here's the thing. There are some classes that are more important than others, right? So like, I personally think the statistics class is the most important class, okay? Probably the English professors disagree with me, but that's okay. What is probably the least important class?
Running.
Yeah, okay. So here's what we want to do. We want to weight it accordingly. So the way your grades are calculated like this, or weighted, is by the credits of each class. Okay, so stats is a 4-credit course, calculus is a 4-credit course, English is 3, economics is 3, and running tends to be 1 credit. So what we're saying is we're going to weight running by 1 value where the stats class is worth 4. So here's our original variable, x sub I, and here's our corresponding weighting variable, w sub I. So if the formula here is the sum of each x value times its weights divided by the sum of the weights. So I'm going to put a new column here called xi times wi. And what I'm going to do is I'm going to multiply across. So 4 times 4 gets me 16. 4 times 4 gets me 16. 2 times 3 gets me 6. 3 times 3 gets me 9. And 1 times 1 gets me 1. So now what you have to do is you have to sum these up. 32, 38, 47. So when you sum up each x value times its weights, you get 48. And now here, you're not going to take this and divide it by 5. You're going to take it and divide it by the sum of the credits here, the sum of the weights. And it looks like Matt was taking 8, 11, 14, 15 credits. So if you take 48 and divide it by 15, Matt's real GPA is going to be a 3.2. Much better?
Yep.
So I encourage you all actually at the end of the semester to calculate your own GPA, using this weighted mean and see if, make sure the college did it right. I would always do this as an undergrad every semester. I'd be like, okay, let me just check my GPA and make sure the college did it right. And then I would always be like, oh, dang, they did get it right. But this is how your actual GPA is calculated. Thank you for the pity laugh there. I appreciate it. Okay.
Professor, can you give me 1 second to copy that?
I'm sorry, say that again?
Can you give me 1 second to copy that?
Yeah, of course, of course.
Thank you.
Gives me a chance to have another sip of coffee. All right, so what I want to do next is I'm going to lecture for about another 20 minutes. Yeah, there is no different notation for weighted mean. Okay, yes, it's always the same. All right, there is no notation for population mean here. Okay, it's just a weighted mean. So what I'm going to do here is I'm going to lecture for about 20 minutes, and then we'll take our 10-minute break, and then we'll come back and finish the class after the 10-minute break. All right, sound okay?
Yes.
Yes, thank you.
Yep. All right, so let me just get started on the next section here. Okay. And this is called the 5-number summary. Okay, this is going to be our introduction to box plots and quartiles. Okay, this is primarily what your homework is about. And also, if you look back in the notes or in the syllabus, we have a midterm in this class. I'll always ask a question on the midterm about this 5-number summary, okay? All right, so what I'm gonna do here first is I'm gonna show you how to do all this stuff by hand with very small data sets, and then we're gonna do an example where we use your calculator to show this, okay? Okay, so this concept of box plots and quartiles, I'm going to actually relate to a new measure of spread, all right, or a new measure of dispersion. All right, so the measure of, give me a second to set this up. The measure of spread or dispersion that works with the mean, okay, is the standard deviation. Okay, but the thing about the standard deviation, it's a fantastic measure. I'm going to talk about it every day. But the thing that's important about it is it can be largely affected by outliers. Okay, and I'll define what outliers are in a data set. Okay, they're kind of these things called extreme values. But so what's the measure of spread that works with the median? Okay, because we learned that measure of central tendency. And it's what's called this interquartile range. So I'm just going to call it the IQR, okay? The interquartile range. And this is a really great measure of spread or measure of dispersion for a data set. So there's two values here, or two words here, excuse me. This concept of a range we know is some type of subtraction problem. Okay, it's some high value minus some low value. But what might be new is this concept of quartiles. Okay, so when you hear quartiles, you think of the word quarter. Okay, so this is kind of like an introduction to measures of position in a data set. So how do we take our data set and divide it up into quarters? All right, so to be able to calculate this thing called the interquartile range, we have to talk about first what quartiles are for a data set. Okay, so for a data set, the first thing you're going to do is you're going to arrange it in increasing order. Okay, so ascending order. So for a data set has 3 quartiles. Okay, we have what's called the first quartile, which we're going to call Q1. We have the second quartile, which we're going to call Q2. And we have the third quartile, which we're going to call Q3. All right. The way we're going to do this by hand, when you see me do this by hand in a second, is you find the first, or you find the second quartile first. So always find Q2 first. So if you remember from the lecture, like we had this special notation for the sample mean and population mean, but we had no special notation for the median of a data set. We just called it the median. Well, now we actually do have a notation for it. So the first quartile is going to be the first 25% of data. The second quartile represents the value for which 50% of data falls below, and that's just the median of a data set. So you're always going to start by finding Q2. That's just the median of a data set. Okay. Then what you're going to do is after you find the second quartile, the median of a data set, you're going to take that data set and cut it up, and you're going to look at the bottom half of data, and you're going to find the median of the bottom half of data. Okay, that's the first quartile. So if the first quartile is 25% of data falls below it, the second quartile is the median, or 50% of data falls below this value. Then to find the third quartile, you're going to look at the top half of your data set, and you're going to find the median of your top half of your data set. So Q3 is the value for which 75% of data falls below it. Okay. So the first quartile, median of the bottom half of data. The second quartile is the median of the entire data set. And the third quartile is the median of the top half of the data set. Now that we know what quartiles are, we can find this interquartile range, this IQR. All right. All it is the difference between the first and third quartile. So it's just Q3 minus Q1. So really what the interquartile range is it's the range of the middle 50% of data. Okay, that's what this interquartile range is. All right, I know it was a lot there and I went through it pretty quickly. But let's do some examples where we find these by hand, okay, in a second, and talk then about what this 5-number summary is. So here's how we're going to find the quartiles, okay? Going to arrange the data set in increasing order. You're going to find the second quartile first, so always find the median. Then you're going to cut the data in 2 halves, the top and bottom half. Then you're going to find the median of the bottom, and then you're going to find the median of the top. Once you have that, once you have the quartiles, you're able to find then what we call this 5-number summary. And a 5-number summary of a data set is the minimum value, the first quartile, the second quartile, the third quartile, and the max of the data set. Okay. Let's do an example. So what I'm going to do here is I'm going to show you how to do this by hand. We're going to do this by hand together. And then you'll notice the slides. If you watch the slides, you'll see that I have a visual of all this, but I want to show you how to do this by hand first, okay? All right, so suppose you just have this random data set. Okay, 12, 6, 4, 9, 8, 4, 9, 8, 5, 9, 8, 10. Okay, and what I want to do is I want to find the median and the quartiles for the data set, the interquartile range, and then eventually what I want to talk about is this concept of a box plot. Okay, so the first thing we're going to do is we're going to arrange the data set in increasing order. So I'm going to take this data and I'm going to order it like this. Okay. So this is one of the few instances where I encourage you to like get a piece of paper and write this data set out and kind of follow along by hand with this. Okay. So the first thing you have to do after you arrange this, so arrange data, you're gonna have to find the median. All right, so if you remember from the online lecture, I showed you how to do this using what's called the n+1 divided by 2 position. Okay, so if you look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data values. So you go 12 plus 1 divided by 2, all right? That gets me 13 divided by 2. That means the median occurs in position 6.5. Okay, so here's position 1, 2, 3, 4, 5. Here's position 6. Here's position 7. The median occurs right here. Okay, so between these two values. So you would take the average of the two values on either side. So the median here, Q2, is the value 8. Right? Do people remember that from the online lecture?
Yes.
Okay, good. All right, so then what you're gonna do is, the next thing you're gonna do is you're gonna find the median of bottom half of data. So what you're gonna do is you're gonna cover up. You're not gonna look at these 6 values here. You're not gonna look at them, okay? You're just gonna look at these 6 values here, okay? So this one you can just eyeball really quickly because it's only 6 values. Can anybody tell me what the median of this bottom half of data is?
5.5.
Yeah, it's gonna occur right here between 5 and 6. So our first quartile Q1 is the value 5.5. Awesome. Then the fourth thing you're gonna do, all right, you're gonna find the median of top half of data. So now you're just gonna look at, yep, thank you very much. You're gonna look at just these 6 values, and Q3 is gonna occur right between these 3, and it's just the value 9. And perfect, right? Like if you watch, right there, we got them. all right? For a small data set like this, very easy to do by hand. I think so. So now we can find the interquartile range. Okay, so the range of the middle 50% of data. So that's just Q3 minus Q1, or 9 minus 5.5, or 3.5. All right, makes sense how I did that real quickly?
Yes.
Okay. So now I just want to go back for 1 second. The visual representation of this 5-number summary it's called a box plot. All right, sometimes it's called the box and whiskers plot. Okay, but I'll always just call it a box plot for this class. All right, so let's now take this data and draw the box plot for it. So this is going to be the visual representation of the 5-number summary. So the first thing you're going to do is you're going to put up a number line here like this. All right, so I'm going to do this one by hand so you can see how to do it. First thing you're going to do is you're going to go to wherever the median was, wherever Q2 was, and you're going to draw a vertical line. Then you're going to go down to the first quartile, which was 5.5. You're going to draw another line. Then you're going to go to wherever the third quartile is, Q3, and you're going to draw another vertical line like this. And then what you're going to do is you're going to connect these three with a box like that. And what you're seeing is this box plot is going to show us where Q1 is, where Q2 is, and where Q3 is. So then the 5-number summary also included the minimum value. So you look in the data set, the minimum is a 4. So you're going to draw another vertical line here, and you're going to draw a whisker out to that. And then you're going to go to your max value, 12, and you're going to draw a value out to that. So this is going to show us the min value, first quartile, second quartile, third quartile, and the max value. And you can see here, you know, I personally think my little chicken scratch is better than the one that's drawn there, but you can see this is the visual representation of it. All right, how many people have seen a box plot before? Okay. All right, just for timing in the class, there's a second example here. I'm not going to work through it too quickly or work through it in much detail. But if you look back here, this one had a 1, 2, 12 and had an even number of data values. If you do it by hand and there's an odd number of data values, just how you handle it is a little different. So imagine you have a data set like this that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data values. So first you find the median. All right, so you'd 11 plus 1 divided by 2. The median occurs in position 6 of the data set. So now when you go to do this by hand, okay, when you go to do this by hand, you want to find the median of the bottom half of data here. So you don't include this median here. Okay, so when you look at this, the median of this bottom half of data is just 4. And then when you go to find the median of the top half of data, do not include this value here. And the median there would be 10. Okay, and then you can find the interquartile range here. And then again, you can sketch the box plot for this very, very easily. Like that. And don't worry, I know I'm going through it fast. We're going to do a much more in-depth example in a little bit where we're actually going to do the whole thing by hand and use our calculator quite a bit. All right, so as we go to the break, let me just talk about some uses of box plots. So box plots are useful for comparing two or more data sets. Like if you want to look at the heights of boys and girls in middle schools, right? Like you can see the 5-number summary here where it's the min value, quartile 1, quartile 2, quartile 3, and the max for both. And just looking at the box plots, you know, you can form a general conclusion here, right? Like in general, just looking at it, boys are taller than girls. All right, in middle school. Okay, like just that's what this direct comparison does for us right here. You can also do it for 3 data sets. Like if you wanted to compare temperatures of 3 cities, so Seattle, San Antonio, and New York, you know, you could just see, well, look at Seattle. Seattle's very temperate. San Antonio tends to be very hot, and New York just is like all over the place. Okay. Box plots. One last thing before we take our break. The whiskers of a box plot can tell us, if you remember from the lecture online last week, if a data set is skewed or not. Okay, so this right here is a right skewed data set, and you can see that the whisker shoots off to the right. So long whisker part here to right, the data is right skewed. When the whiskers are roughly the same like this, okay, and the median falls in the middle of the box, you can see this looks like the bell curve, or it's symmetric. And over here, the opposite of right skewed. So when you have a long whisker to left, what that's saying is the data set's probably left skewed. Okay. All right, what do you think? Good place to take a break? And we'll come back, we'll talk about outliers.
Yeah.
I think it's a good place to take a break. Okay, so what we'll do here, break time. We'll start back up at 10 a.m. Okay, so everybody can you guys see my clock on my screen there?
Yes.
Okay, we'll start back up in 10 minutes, everybody. Okay, so enjoy a little bit of a break. I'm gonna go refresh my coffee, check on my wife and son, and we'll come back in 10 minutes. All right, everybody. Let's get back to it. I hope everyone enjoyed their break. I refreshed my coffee, so I hope if you guys are having coffee, you did that as well. Now, we're going to use our graphing calculators quite a bit in the next section. So if you have your graphing calculator, take it out and follow along. Now, I'm going to have up on the screen here, I'm going to show a TI-84 emulator. Now, how many people have a TI-83? So if you have a TI-83, that's perfectly okay. Whenever there's an example in class where the options on your calculator are exactly the same, no matter if you have a TI-83 or TI-84, I'll always show the TI-84. There are, when we get to some of the more advanced topics, there are slight differences between how you input stuff in the TI-83 versus the TI-84. When we have that case, I'll always load up both of them. Okay, so I'll load up both the TI-83 and TI-84 so people in class don't feel left out. But for this simple stuff, the options are the same. So even though I'm using a TI-84 here, your TI-83 how you input it will exactly be the same. Sound okay? Okay, good, good, good. You're welcome. You're welcome. I don't want the TI-83 to be left out. Okay, so now what we want to talk about is outliers, and specifically outliers and how they relate to the 5-number summary and box plot. Okay, so what an outlier is, it's an unusual score relative to the data set, and it's going to influence the value of the mean and standard deviation. So what outliers are is there extreme values in a data set. Okay, unusual or extreme values. So a data set, when you have one, might have no outliers, one outliers, or several outliers, okay? And how you identify outliers are using what's called the upper and lower limits. Now, there is no specific theory behind these formulas. Like a lot of times in class, I say, okay, here's the formula. It makes sense how you do it. These formulas are just what statisticians have agreed over time as ways to identify outliers. Okay, so outliers, you can be extreme or unusual values, can be low. You could have a low outlier, so a value that's really, really low compared to the others, or a high outlier, okay? So outliers can be one of two ways. So as such, you need to calculate these two formulas. You have the lower limit here, and what you take is you take the first quartile of the data set, and you subtract 1.5 times the IQR. This I also like to call as a cutoff value. Any value in your data set that falls below this lower limit is an outlier. The upper limit, you take the third quartile and you add 1.5 times the IQR. Okay, this is the lower cutoff value, and this is the upper cutoff value. Okay. And any value below the lower limit is an outlier. Any value above the upper limit is an outlier. Okay. So what I want to do here is, instead of like in the previous examples where I just had the answers on the slides, I want us to actually work this all out together so you can see it, okay? All right, so what I have here is I have this data set, and let's just say it was how many minutes students spent watching TV last night, okay? I don't know, Sunday night, I don't know if people were watching TV or not, but let's just take this as time spent watching TV last night in minutes. Okay, in minutes, sorry about that. So it looks like there's 20 data values. So my sample size here is 20. Okay. Do any values look unusual compared to the rest? So when you look at the data set, okay, Does any value seem really high or any value seem really low compared to the others?
Yes.
Yeah.
166.
Okay, so this looks high compared to the others. Okay. Yep, and exactly 5. This looks low. Okay. But now here's the thing. What you cannot do is you cannot just eyeball a data set like this and say, oh, that's the high value, that must be an outlier, and that's the low value, that must be an outlier. Okay, so what I'm going to do, what I'm going to walk you through is exactly a question that you'll get on your midterm, like in a couple weeks. Okay, so you're going to have a data set like this, and it's going to say the following things. Okay, question 1. So Q1. Find the quartiles. Okay. Now you could do this by hand. Okay, like you could take the data set and you can arrange it by hand, but I'm going to be honest with you, it sounds awful. Okay, so the good news is for this class, you never have to do that. All right, so I'm going to show you how to do this in your calculator here. Okay. If you remember from the videos last week, I showed you how to do this as well. But does anybody remember, just out of curiosity, I want to find descriptive statistics, or what's called 1 var stats. Does anybody remember what button you press first on your calculator to input data? Yes. Okay, so the button we're going to use the most in this class is this stat button right here. Okay. Later on in class, we're going to use this DISTR, this distribution button, and we'll also use this stat plot a little bit. Okay, but like let's just press this stat button here. And right at the top, you see these following things. You see edit, calc, and tests. So when you want to take raw data and put it into your calculator, you want to do edit, and then you want to do edit 1 here where it says edit. So you're just going to hit enter. Now this is important. Does anybody see something other than L1 on their calculator? Okay. If you do, you'll have to reset your calculator. Okay. And in the coming classes, I will show you how to reset your calculator. But for now, if you see L1 there, that's fantastic. Now, what you're going to have to do now, it's a little arduous, but there's 20 data values. You want to take them and plug them into your calculator. So start with 25, and then you're going to hit enter. Then 66 is the next value. Then 34. Then 30, you're gonna have to keep going. 41, 35, 26, 38, 27, 31, 32, 30, another 32, 15, 38, 20, 43, 5, 16, and 21. Okay, so plugging it in there. So if you're following along in your calculator, I'll pause for a second so you can finish inputting the data yourself. Okay. So now what you have is you have the data plugged into your calculator. Great. So I'm going to go back to the calculator options here, and I'm going to press the stat button again. Okay. Now what I want my calculator to do is I want them to calculate the basic statistics for us. So I'm going to scroll over till calc is highlighted. And you're going to see all these options here. Okay. The one option for very simple 1 variable statistics is option 1 right here. Next week, we're going to learn, we're going to use 2 var stats a little bit. That's just if you have 2 columns of data. And we're going to use this option number 4 here, linreg, a ton next week. Okay. But for now, we just want this 1 var stats. So I'm just going to hit enter. Now, if you have a TI-83, okay, what you should see on your calculator is it should just say 1 var stats. Okay. If you have a TI-83, just hit enter. Okay. Just hit enter again. If you have a TI-84, it says, what list is your data in? L1, yep. So you're just going to scroll down to calculate. And you're going to hit enter. All right, now how many people see this right here? If you're able to do it. Okay. If your values look a little different, generally what happened is you might have inputted one value incorrectly. Okay. If you put a 43, a 44 instead of a 43, your values are going to change just slightly. Okay. So right off the bat, this is what you see. It tells you X bar. It says, okay, the average of this data set is 30.25. You scroll down here, you see this S sub X and this sigma sub X. Okay. S sub X is the sample standard deviation. Sigma sub X is the population standard deviation. So your calculator does not know if your data set is a population or a sample. So what it does is it literally just gives you both values. Okay. It just says, okay, you know what, here, take both. And then you can pick one you want. So just be mindful of that. You will notice, okay, this is important because I'll ask this question on the midterm. You will notice that it gives you the standard deviation, but it does not give you the variance. Okay. If you have the standard deviation, does anybody know how you could use the standard deviation to find the variance? So if you have yes, exactly. If you have the variance, you square root it to get the standard deviation. If you have the standard deviation, you square it to get the variance. Awesome. All right, you'll notice this little arrow here. If you press scroll down, you'll see the following. It'll tell you the min value. Q1 is your first quartile. Median, that's your second quartile. And Q3, that's your third quartile right there. All right, and then max, that's your max value. So is it easier, even though doing it by hand was pretty straightforward, is it much easier just to ask your calculator to do this stuff? Absolutely it is, okay? So whenever you can in this class, use your calculator, okay? That's why we have it. All right, so have this handy out in front of you. I'm gonna go back to the slides a little bit. Okay, so going back to the slides. Q1, if you look back on your calculator, I think Q1 was at 23. Did I remember that correctly? Yeah,
Yep.
I think so. Okay,
Yeah.
awesome. Okay, Q2, the second quartile was the median. That was 30.5. And Q3, the third quartile here, that was 36.5. Great, right? Okay, second question from this data set. Find the interquartile range, IQR. Okay, what was the formula for the IQR again? Can anyone tell me?
Q3 minus Q1.
Yep. So this, you just take 36.5 and you minus 23. And I think that you get 13.5. So that's the interquartile range. So that's the range of the middle 50% of data. Okay. Third question. Let's identify any outliers. Okay. So we have this data set and we think 66 is a high value and 5 minutes is a low value. Okay, but so we want to exactly identify them as outliers. So you have to calculate these cutoff formulas. Okay. So you need the lower cutoff or the lower limit. And the lower limit is you take quartile 1 and you minus 1.5 times the IQR. So look, quartile 1 is 23 minus 1.5 times this interquartile range you just found. And can anybody with a calculator plug that in for me and tell me what they get? I'm asking for help on this one.
Got 2.75.
Yeah, okay. Thank you, that's exactly what I got. Okay. So I'm saying the lower cutoff is 2.75. So look at the data set, okay? Is there any value lower than 2.75?
No.
Okay, no. So even though we thought 5 was low, all right, it's not an outlier. It's close, but it's not an outlier. That's why you need to do this testing, okay, to make sure. So even though it looks close, not an outlier. All right, so let's do the upper limit now. So you take Q3 plus 1.5 times the IQR. So Q3 here, you take 36.5 and you add 1.5 times that IQR, which is 13.5. And can anybody help me out with that?
Yeah, it's 56.75.
Thank you. I appreciate that help there.
Well,
I'm a little lazy today. All right, I'm only on my third cup of coffee. Okay, so now look at your data set. Is there any value above 56.75?
Yeah.
Yeah, okay. So that means that 66 is an outlier, okay? So 66 is an outlier. Okay. Now what we want to do, excuse me there, now that we have an outlier, we have the quartiles. Question number 4 is, let's sketch the box plot with the outlier. All right, so how you show the box plot with the outlier is a little bit slightly different than how you would show it with an outlier is different from how you would show it without an outlier. Okay, so you're going to do this by hand. You're going to start by drawing a number line, okay? And you're going to start it at 0, all right? And you need it to go all the way up to 66 at least. So I'm going to go by 10s here. So 10, 20, 30, 40, 50, 60, and 70. Okay, so if you remember how to do this, go to Q1. Go to the value 23. So I'm going to eyeball it. You're going to draw a vertical line. Okay, there's Q1. You're going to go to 30.5. So that's kind of like right here. Okay, that's Q2. You're going to go to Q3, which is 36.5. So that's kind of like right here. And this is going to be the main part of your box plot. Okay, right there. All right, so the next thing you do is you go down to the minimum value. Since this is not an outlier, you go to the value 5 and you draw the whisker out to it here. Okay? Now the next thing you do, okay, notice how we said 66 was an outlier. What you do not do is you do not draw the whisker out to 66. You go to the value 66 and you put a little asterisk right there. Okay, that's your outlier. Then what you do is you look back in the data set and you say, okay, what was the next highest value that is not an outlier? Is it 43 is the next highest value? Yeah. So then what you would do is you'd go to 43, you draw the whisker out to that value right there. So we have min, first quartile, second quartile, third quartile, the max value that's not an outlier, and then that outlier on the data set. Okay, not too bad. Do you think you could handle something like this on an exam? On the midterm?
yeah, definitely.
Yeah.
Yeah, you'll get a question like this on your homework too this week. So what your homework will ask you to do this week, you'll see is it'll give you a data set and it'll say, okay, hey, you know what? Find the quartiles and then just test for an outlier. Okay. So, you know, you've seen me do an example here now like this. All right, I do want to show you real quickly how to do a graph in your calculator. Okay, and how you do it in the TI-83 is exactly the same as how you do it in the TI-84. Okay. So do you see this option on your graphing calculator called stat plot? Okay. Your calculator initially has stat plot turned off. Okay. So what you're going to do is you're going to hit second function and then stat plot. So second function y equals. And you should see something like this. It should say plot one ... off. Okay. So what I want to do now is I want to turn it on. So under number one, I'm going to hit enter. Okay, you see how it's blinking on here? I'm just going to hit enter again. And then you see all these different options here, right? Like that looks like a histogram. We've done histograms before. This right here, this is what's called the scatter plot. You're going to do this on your own this week. But do you notice here, you see two box plots? Do you notice this first one here has these dots here? That means a box plot with outliers. So I'm going to scroll down to it. And on it, I'm going to hit enter, okay? All right, now normally if you wanted to see what the graph looks like now, you would normally, don't hit this exactly on your calculator, you would normally just hit the graph button. And when you do, you should see something like this. That's because your calculator is currently zoomed to the center of the Cartesian plane. So what you want to do is you want to hit this zoom button right here, zoom. And you see this option, it's option number 9 called zoom stat. So you can scroll down to it until you see zoom stat. And just hit enter. And now look, here's what the calculator says the box plot looks like. Does mine look like the box plot here?
Yeah, pretty much.
Yeah. Yeah. I mean, I personally, do you guys think my drawing's a little bit better?
Yeah, of course.
Obviously, yes. But you can see here, like your calculator tells you that there's an outlier for you in it as well. Okay. So your calculator picks this up. All right. You can have it even do the, like if you were to just not selected this one, but instead it selected this one, it shows you the graph without the outlier. But if you have this, it'll show the outlier. The good news is if you have this one selected and the data set does not have an outlier, it won't show the outlier. So it's just better to have this one when you want to do a box plot. All right. And don't stress, we're going to get an opportunity in the coming weeks to practice with our calculator a ton. Like every day in class going forward, we're going to load up our calculator and we're going to redo graphs and everything. So don't stress if you're like, I didn't exactly get all the options. It's not a big deal. Okay. So just for time's sake, I want to move on to our last topic. This, I think, is a really good example for you to see how to do this. I'm not going to do another one. If you want to practice a little bit on your own, I have an example here with ages of actresses at the first time they won their Oscar nomination or won their Oscar. And I give you the statistics here. And I ask you to find an outlier. So it turns out if you do this by hand on your own, you're going to get more than one outlier, and that's okay. So you'll get, I think, 3 values that are above the cutoff value, okay? But just with the time we have left, I just want to move in now and talk about our final topic for today is z-scores, okay? In z-scores, this is a simple concept but it's going to be one of the more important concepts. All right, in future classes. So basically, z-scores are going to be a very simple idea here today, but then later on in our course, we're going to be calculating z-scores pretty much every day. So this is just a very, very brief introduction to it. Okay. So the first thing I want to talk about is how and why we need them. Okay. All right, so I want to talk about two teachers, okay? So I have this teacher, Jeff, right? And Jeff makes $70,000 a year, let's say. Okay, so two teacher salaries. And I have this teacher, Nicole, and she makes $60,000 a year. Okay, so these two teachers. So let me ask this question. Who is better off? Who's doing better off in their career?
Jeff.
Okay, why would you say Jeff?
He's making more.
Okay, you're making more. You do have a good point there. We don't know. Okay, so just specifically right now, you are right that we're going to need a little bit more information, but just based on income, Jeff seems better off. Okay, just based on income, it looks like Jeff is doing better. Okay. And I picked Jeff and Nicole, just a little piece of information, brother-in-law and my sister's name. Okay, so that's where they came from. All right, but let me give you some extra info, okay? Because in the chat, someone said, we don't know who's better off. Because you're right, because like all we have is income to look at, okay? So maybe there's some other information that we need to take into account here. Okay, so Jeff lives in New York City, and Nicole lives in the greatest city in the world, Albany, New York. Okay. Would you guys agree that Albany, New York is the greatest city in the world? Has anyone ever been to Albany? I grew up in Albany. That's why I say that. Okay. It's a little bit of a joke. Okay. We all know New York City is the best, but so looking at this, okay, Jeff makes $70,000 in New York City. Nicole makes $60,000 and lives in New York. Who would you say is better off?
Nicole.
Okay, I just curious. The cost of living in New York City. Yeah. Okay. So, looking in the forums or in the chat here, everyone seems to think Nicole. So here's the thing. Maybe Nicole is better off. Okay. Maybe. Okay. Yeah. So what I'm getting at here is it's an unfair direct comparison. Okay. Because yes, his expenses are higher, absolutely, but he also makes $10,000 more a year, right? Like, so it's an unfair direct comparison. Okay. So in statistics, what we do is it's better to compare the relative positions to their peers. Okay. So look at relative position to their peers. So what I have to do is I have to give you a little bit more information, okay, to be able to do that. Okay, so to do this, we need to know the mean and standard deviation for the salaries in their locations, specifically teacher salaries. So in New York City, let's just say, I know, just to be clear, I made these numbers up, okay? I'm not exactly sure, so I don't want you to think these are true, but I just made these numbers up. So in New York City, the mean teacher salary is $80,000 a year and the standard deviation is 20. In Albany, the mean teacher salary is $50,000 a year and the standard deviation is $5,000 a year. So now who is better off? And can anybody tell me why? So relative to peers.
Nicole.
Nicole is definitely better off. Okay, but like why?
Well, because in New York City, like the mean amount to make is $80K and the other guy had $70K, while she's making more money in Albany than the mean.
Yeah, that's exactly right. Okay. So now it's just, instead of just eyeballing that and recognizing that, let's put a calculation to this, a formula for this, so you can see it in action, okay? This is what's called the standardized variable or a z-score, okay? This is a unitless measure. Okay, so even though we're talking about incomes here, like dollars per year, when we calculate this standardized variable, it is unitless. There's no like dollars, okay? So for a variable x, and in this example, the variable x is their salaries. So the x variable for Jeff was 70,000, and the x variable for Nicole, well, she was making 60,000. Okay, and all you do for a z-score is you take the variable minus, does anybody remember what this is the notation for? Yep, you subtract away whatever the mean is, and then you divide it by, does anyone remember what that's the notation for?
Standard deviation.
Yeah. Exactly. Okay. This is called the standardized version of it. Really, as you can see here, this is what I call a z-score. And what a z-score tells you is it tells how far a data value is from the mean in terms of standard deviation. So in terms of the number of standard deviations. Okay, so if you calculate this value and it says, okay, well, we have a z-score of 5, okay, that means you're 5 standard deviations above the mean. If you calculate this and you have a z-score of -1, that means you're 1 standard deviation below the mean, and that's it. So just using these simple examples here, okay, let's calculate the z-scores for each year. So you can see Jeff's z-score, okay. Jeff was making $70,000 a year. The mean in New York City was 80,000. Standard deviation was 20,000. So this is how you get a unitless. 70,000 minus 80,000 is minus $10,000 per year, divided by $20,000 per year. Dollars and dollars cancel out. So there's no unit there. And 10,000 divided by 20,000 gets you minus 0.5. So Jeff is making 0.5 standard deviations below the mean for people in New York City. Whereas Nicole, okay, she was making 60,000 minus 50,000 is 10,000 divided by 5,000. She's 2 standard deviations above the mean. So just by looking at this, we can see, you know, just what everybody thought in the chat, Nicole is actually better off, okay? And she gets to live in Albany, which is just so fantastic, okay? I always like to joke about that because I grew up there. It has a really good mall and no sports teams, but, you know, there's a lot going on there. Okay, that was a joke. All right, let's just do one more example here to end class, okay? So we have 2 students, okay? We have the student Mark and the student Steve, okay? So Mark took a calculus final exam and Steve took an economics final exam, okay? Mark, he scored a 71 on the exam, and the mean exam score in the calculus. So the mean was 76 and the standard deviation was 5. Okay. For Steve, he took an economics final exam and he got a 75. So he actually got a higher value than Mark. Okay. But the mean for the economics final exam was an 88. Ugh, yeesh. And he got a standard, and the standard deviation was 10. Okay. So who is better? Who did relatively better? All right. So whenever you see a question, like when you get to the midterm, yeah, we'll actually calculate the z-scores. Whenever you see something that says relatively better, you need to calculate z-scores though. Okay. You have to justify it. Okay. And so just remember, a z-score is the x value minus the mean divided by the standard deviation for the data set. Okay. So the z-score for Mark, you would take 71 minus 76 and divide it by the standard deviation of 5. So you would get minus 5 divided by 5. His z-score is -1. Steve, on the other hand, okay, you would take 75 minus 88 divided by that standard deviation, which is 10. 75 minus 88, I believe, is minus 13 over 10. And you get minus 1.3. All right. So what we're saying here is Mark is 1 standard deviation below the mean, whereas Steve is 1.3 standard deviation below the mean. So I know it's posted in the forum there, but who did relatively better? I'm looking at the z-scores now.
Mark.
Yeah.
Mark.
Yeah, calculus is a little bit harder than economics, I would think. All right. What do you guys think? We end class a little early today. Is that okay?
Sounds good to me.
Yeah.
All right. Let me just real briefly go back to the classroom real quick. I just want to talk about something real quick. Okay. So what I'm going to do, instead of posting the recordings under course meeting materials, what I'm going to do is I'm going to put a new tab right above week 1 that's going to say class recordings. And I'm going to post my saved file here for you there, as well as the recording from class, instead of just burying them under the tabs here. On your own this week, okay, so the week 2 tab here, if you want, there's a review lecture on box plots, okay? But your big thing here is going to be this correlation and regression, okay? You're going to notice I have a calculator emulator loaded up here. You're going to have to pay a lot of attention to that because there's a lot of like little buttons you have to press to change settings in your calculator. But don't worry, if you struggle with it, let me know. You can swing by my office hours. So what I'm hitting at here is I wouldn't wait till Monday night to do this homework or watch this lecture because I only have office hours on Thursday and their homework is due Monday night. So give it a shot, you know, maybe Wednesday, and then come to my office hours on Thursday if you need help with your calculator. It's going to involve reading a statistical table a little bit to get what's called critical values. And there's a lot going on in that lecture. So make sure you review it. And then your online quiz this week. Let me just. No, actually, I do want to do that. Sorry. Your online quiz this week. You can see it's a data set, a lot of quartile stuff, interquartile range, testing for an outlier. And then this stuff you can see is new stuff. Okay, so you're gonna have to watch the video for this stuff. Okay. All right, class. Yes, yeah. On exam days, you will be given. Are you talking about like for those correlation critical values? Is that what you're talking about? Yeah, yeah. I'll give you those. Yep. All right. Any other questions before I close out for today? Yeah. So it's going to come quickly. Believe it or not, your midterm exam. Like it's actually like a month away. It's going to come pretty quickly. But as we get closer to your midterm exam, I know it's weird to be talking about it during week 2, but as we get closer to the midterm, I will help you and prep you for the midterm with stuff that you need. Okay.
Sounds good.